Hi, my name is Chartier. I'm going to solve this math problem. So first off, in the numerator you can see that they're trying to give you a factorial, and that's actually what will be in the parentheses. So you'll have this series from n equals 1 to infinity of 2n minus 1 factorial over 5n n factorial. So then I'm going to use the ratio test, which by definition is the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And the a sub n in this case is that whole problem. So then using that, we'll have the limit as n approaches infinity of the absolute value of, and now you want to substitute n plus 1 where all the n's are. So you'll have 2n plus 1 minus 1 factorial over 5 to the n plus 1, and then n plus 1 factorial. Now that'll be multiplied by the reciprocal of the original, which will be 5 to the n times n factorial over 2n minus 1 factorial. Now you'll simplify, and I'm actually going to separate out each fraction. So I'll have limit as n approaches infinity of the absolute value of 2, and now simplifying this, you'll have 2n times, or plus 2, and then subtracting 1 from that, you'll get 2n plus 1 factorial over, and then I'll put it under this one because that's the one that matches up with 2n minus 1 factorial multiplied by 5 to the n over 5n plus 1 multiplied by n factorial over n plus 1 factorial. And an absolute value. Okay, so then, trying to cancel some stuff out, you can increment the factorial down 1, but also multiplying it like they do here. So you'll have 2n plus 1 times 2n times 2n minus 1 factorial all over 2n minus 1 factorial. So then these will cancel out. So then you multiply that by 5 actually. So you'll have 1 5 to the n on top and 1 5 to the n on bottom, add another 5. So then when they cancel them out, you'll have 1 over 5 multiplied. And now you can do the same thing you did here by incrementing this down 1. So you'll have n factorial over n factorial times n plus 1. So the n factorial will cancel out, so you'll have 1 over n plus 1. And then, so now you can take the 1/5 out in front of the limit based on the limit laws. So then limit as n approaches infinity of the absolute value. So here you'll have 2n plus 1 times 2n over n plus 1. So now you can either FOIL these out, or you can see that there's 2 n's on top that when multiplied together will be n squared, and 1 on the bottom. So based off that, it'll automatically, when put to infinity, will automatically equal infinity, which is greater than 1 based on the ratio test, which makes the original problem, the sum or series from n equals 1 to infinity of 2n minus 1 factorial over 5 to the n factorial, this will diverge.